So when we are solving trig equations, we are going to do some factoring today, and we're going to have two kind of types of factoring that we've mostly dealt with in math. And those would be like when we factor into the two parentheses, the two binomials, and we're trying to undo first outside, inside, last. And the other kind of factoring that we've done is we've pulled out common factors. So some example of what you will see today is I'm going to ask you to solve, and because we're talking about trig values, they have actually infinite answers. They repeat every 2 pi. So I'm going to ask you just to solve on the interval 0 to 2 pi. Okay. And so what I'm going to ask us to solve is the equation that the cosine squared of x plus 2 cosine of x plus 1 equals 0. Okay. And so at first you might think, I don't understand how I'm going to factor something like this. Well, I want us to go back to our days. Let's pick a different variable. Let's say I asked you to solve using the zero product property. Let's do it on the side here. Y squared plus 2y plus 1 equals 0. Can you factor that for me, please, a minute? Turn and look at your partners a minute, see if they get the same thing as you. Did you all write y plus 1 times y plus 1 equals 0? Y would equal -1. Okay. So the only difference today is I'm not gonna be solving for x quite yet. The function that I have is that the cosine squared plus 2 cosine of plus 1 equals 0. So it's not the x squared, it's that the cosine is squared. So how I'm going to start this problem is I'm going to write 2 parentheses, and I'm going to ask myself, what would go in the first spots in order that I get a cosine squared? A cosine of x and a cosine of x. That's how I would get a cosine squared. Let's go to the last term, this plus 1. What would need to go in these last spots to multiply to be 1? 1. And since this is a plus 2, it would have to be plus 1 and plus 1. Whereas if it was a minus 2, it would be -1, -1. So now, this isn't, again, I'm not quite solving for x yet, but it's going to allow me to solve for x. Because now, just like before, I set this equal to 0, and hopefully we all agree it's the same exact factor this time, so I don't have to do it with the other one because it's the same. And this is where I'm going to solve on the interval 0 to 2 pi. If I moved this to the other side, what I'm asking is, where on the unit circle does the cosine have a value of -1? So on our unit circle, over here, the cosine is -1 and the sine is 0. So right here, it has a value of -1. So the solution to this would be x equals pi. That's where that's true. Okay. So are you kind of getting the concept? Let's try another one that is common factoring. Okay. And lastly, we'll try one with like a tangent, and then you're going to try some. All right. So this time, we're going to solve on the interval 0 to 2 pi. And I'm going to solve 2 sine of x times the cosine of x minus the sine of x equals 0. Okay. And this is kind of new because we're not used to maybe seeing things like written in this way, but what you have to remember is we've done, I think if I said 2xy minus x, that wouldn't be an issue, but I'm throwing these trig words in. Whenever you have something that's all multiplication, we consider that to be one term. So this whole thing is one term, and it's made up of 2 times sine times cosine, okay? It's all one term. This is another term. What do they have in common? They both have sine of x in common. Go ahead and box that. Okay. So this is where I'm going to use kind of, I call it common factoring, if they have a common factor, or we talk about pulling things out to the front. So what I'm going to do now is I'm going to take that sine and I'm going to pull it out to the front. So it's 2 sine of x out to the front. And now, thinking of this term, and remember I just pulled it out, I divided it, okay? If I took this and I divided by sine of x, what would be left? So I just divided off the sine of x. Oh, that's the number 2. If there were 2 sines, it would be sine squared. You see what I'm saying? Like it would be sine times sine. So 2 sine just means 2 times the sine times the cosine. So if I divided the sine off, there would just be a 2 times the cosine of x. And sine of x divided by sine of x would just be 1. Okay. Those are really good. I'm glad you said that because that's a really common thing to try to do. Like, because normally we see like 2 times x times y, like most people wouldn't make that mistake with that. Because we see the 2 sine, it just throws us off for some reason. All right, let's do our solving and using our unit circle. There are 2 factors now. So I have to find where sine of x equals 0. And I also have to find where 2 cosine of x minus 1 equals 0. Okay. This one is, again, remember I said on the interval 0 to 2 pi. So go ahead and either grab your unit circle out or put it in your head. There are 2 spots where this happens. Would you find them for me, please? And then this one is cosine of x, 2 cosine of x equals 1, and then we divide by 1/2. Okay, so along with your partner, there's 2 of you that don't have a partner. Just peek at the person in front of you or behind you. Would you find the 2 values where sine of x equals 0 on the unit circle, and would you also find the 2 values where the cosine of x equals 1/2 on the unit circle? Okay, remember sine is on the hand trick. Sine on the hand trick is the one below, and cosine is the one above, if that helps if you're using hand trick. Okay. Great stuff, guys. Great stuff. All right, so these are the three answers. Wait a minute, three? These are the three answers I saw somebody put down, and then I'm going to talk about how you would write it, just given by how I asked it in the question. This is at the beginning of the unit circle, which is actually not the sine cosine 0, it's the angle 0, because it's just begun. Also at pi, it happens. Some people wrote pi and 2 pi because they said, well, it happens at 2 pi. Yes, but 2 pi is the same as what? 0. Now, technically, since I wrote it as you want to include the 0, a parentheses means you don't include it. This is the correct answer. But are you right it occurs at 2 pi? Yes, you are. Right, it occurs at 2 pi. It also occurs at 4 pi and 6 pi and whatever. All right. And then where does the cosine x equal 1/2? I always find the 1 and then I just flip. So it equals 1/2 up here, which is at pi thirds, and it also equals 1/2 down here, which is at 5 pi thirds. Very nice. Very nicely done. Okay. The last one I'm going to do is one with tangent. And I'm also going to weave into this how you would address it if I don't give you just an interval. So solve, give all solutions to the equation that the tangent squared of x equals 1/3. Okay. The nice thing about this is it doesn't involve any factoring. The bummer about this is we have to think a little bit harder on tangent. Okay. So how do you think you would undo the squared? Yeah, well, it is tan by tan, but there's not a 0 there, so I think I'm going to just take the square root of both sides. Can I do that? When I do that, do you remember I have to add a plus or minus to the front? And please be careful because we need to make sure we list all of them. This leaves me with the tangent of x equals the square root of 1 is just 1, isn't it? And I don't know the square root of 3, but that should seem familiar to you. Has anybody seen that like before that you've recognized I've asked that before with tangent? You might not remember right away like where it is, but yes. Yeah, it happens when, I'm going to draw it right here. It's going to happen when you get, because tangent is sine over cosine, so it's when the y coordinate is a 1/2 and the x coordinate is a √3/2, because then when you would do this divided by this, we talked about how you can kind of ignore the 2's, that part's going to cancel. You would get 1/√3. Are you seeing that? And what angle is that? Pi over 6. Oops, I dropped something though. Okay, if I add that in the mix, that just means it's going to be all of the sixths, plural, because it's going to be here, it's going to be here, here, and here. Can we remember all of the sixths? Yeah. Let's see. On one cycle I can. It's pi over 6. What's this one? 5 pi over 6, 7 pi over 6, and 11 pi over 6. And then here, now I'm going to tell you how you address all solutions. It's super easy actually. How often does these repeat? Like if I wanted to go around again, wouldn't that happen after 2 pi? So the way I could do that is I could take like this whole solution set and say plus 2 pi n, meaning any multiple of 2 pi, it's going to also be the same. So when I ask for all solutions, you literally just do the same thing, but you add on at the end that it would repeat after 2 pi. Okay. So